This is Emma. This is the pinwheel. Which of these pinwheels must be Emma's?
Well, that's the. I think the key to this problem is to look at which pinwheels have the colors that match up in the same pattern as Emma's and the bottom pinwheels. So, let's see. One detail of the pinwheels is that the two white squares are across from each other. So, do you have any ideas, Leo, on which ones that we can eliminate?
Yeah, right off the bat, we can tell that the pinwheels A and B will not work for this question because in A the white triangles are just not opposed from each other. So we can right away eliminate those. But for C, D, and E, they all have the white triangles opposite each other. So I'm not quite sure how to proceed from here. Any other details you notice from Emma's pinwheel?
Yeah, I think there's that gray triangle too. It's next to the one of the white triangles, and it's on its right. What do you suppose that could mean, Leo?
Well, it means that you don't just have to have these opposing white triangles, you also have to have kind of clockwise one triangle over from one of them. You have to have the gray one. So looking at C, we can see that it's actually not in the correct place. They are opposed, but it's clockwise one to the left. So it's not C. And D has the same exact issue, which means the answer must be E.
That sounds about right. Yep. A lot of you in the chat are saying E as well. Let's say if we're all right. And the answer is, drum roll please, it is E. Well done, everyone. Well done. Excellent job. Let us move on to the next problem. I can read this one. Sorry, let me scale it down a bit so you guys can all read it too. Let's see. Can you all see it? I can all see it. James and his little sister play with shells and marbles in their play shop. Each shell has a value of 6, and each marble has a value of 1. Which of the following has a total value of 16? How do you think we should start with this problem, Leo?
Well, I think we should just figure out what the total value of A, B, C, D, and E are, and then see which one is 16. Yeah. Let's start with A. All right. So for A, we have 2 shells and what's that? One little marble? Yeah. 2 shells, 1 marble. So let's do 2 times 6, because 2 shells, each shell is worth 2, plus 1, because 1 marble, which is worth 1. And that would be 13. Okay, so I suppose it's not A, because we're looking for something that's worth 16 exactly. How about B?
Well, let's see. B has 1 shell and 6 marbles, so it's 1 times 6 plus 9 times 1, which gives us 6 plus 9, which is equal to 15. So close, so close. But unfortunately, it is not correct either. Leo, do you want to take a look at C?
Yeah, sure. C's got 3 shells and no marbles at all. So that would be 3 times 6 equals 18. So still not quite right.
Right,
how about D?
All right, let's take a look at D. D has 1 shell, 5 marbles, which means that it is 6 times 1 for the 1 shell, plus 5 times 1 for the 5 marbles. So that's 6 plus 5, which is 11. Still not 16. At this point, we've eliminated all the answers. Would you like to do the honors of calculating E, Leo?
Yes. It has to be E because it's not any of the other ones, but just to make sure, let's calculate it out. 2 times 6 plus 1 times 2, or rather 2 times 1, equals... Oh, actually not 2 times 1. It should be 4 times 1. And that is indeed the 16 we're looking for. So the answer is E.
All right. Yes. Okay, excellent. I see a lot of you have been saying E in the chat. Let's see if we're all right. Let's see. Ooh, wrong slide. Ooh. Yes, it is E. Oh, it looks like the picture is. It was the dice stole the shells. Yes, they robbed the store. It is E. It is E.
Yes. All right, next question. This one seems a little more challenging. That's because it's question number 13 on the 2025 Math Kangaroo grades 3 and 4. I'll read this one out. In the petting zoo, Renee feeds 6 sheep. She gives them a total of 210 grams of dry food for lunch. She gives the smallest sheep, which is this cute little sheep pictured right here, twice as much food as she gives to each of the others. How much does the smallest sheep get?
All right. Wow, this small sheep is getting fed really well. But
Probably to make it like grow large like the other sheep.
yeah, it needs the nutrients to grow big and strong. Okay. So let's see. Let's start off with this problem. We don't know exactly how much food each sheep gets, but we do know that the smallest sheep gets twice as much. How do you think we could use this information and the information that there are 210 grams in total to find how much food each sheep gets?
Well, I suppose we could assign a variable. That's a great way to solve a problem like this. Maybe we could say a regular sheep gets X grams of dry food for lunch, and since they all get the same, all of them get X. So X, 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 except for the little sheep. That little sheep actually gets 2X. So totaling that all up is, yeah, I actually see it in the chat. Thank you, Vihad. So that would be 7X in total.
Yeah. And since we have 7X in total, and we know the total is 210 grams of dry food, we can set those equal to each other so that we get 7X is equal to 210. So now we can do some algebra. We can divide both sides of this equation by 7, which gives us X equals 30. Now there's one final step here. There's one final little trap step here. Do you see it, Leah? The final step?
Yeah, I was gonna say, why is none of the answer choices 30? Isn't the answer just 30?
Well, there's a little trap. See, we're asking for how much the smallest sheep gets, which is not in fact X, but 2X. So you actually have to double 30 to get the answer, which gives, would you like to do the honors, Leo?
It would be 60. Or answer choice B.
Yes. Ooh, a lot of you are saying B in the chat. Well, the chat has proven to be pretty correct so far. Let's see if they manage to do it again. And yes.
Fantastic.
Excellent job. Let us move on to the next problem. I can read this one. 6 ladybugs. Ooh, let me make it smaller so you guys can all see it too. 6 ladybugs have 1, 2, 3, 4, 5, or 6 spots each. Marta took 4 photos of them in groups of 3. Each ladybug appeared in the same number of times in the photos. 3 of the photos, along with the outline of the 4th photo, are shown here. How many spots do the 3 ladybugs in Marta's 4th photo have in total?
This one seems really challenging. I'm not really sure where to start. But I do know that all of the ladybugs show up the same number of times in the 4th photo, although I don't quite know how many, I don't know which ladybugs are going to be in the 4th photo. How would I figure that out?
That's true. Maybe we can look at the total sum of things. After all, we're looking at the, oops, I think I wrote over the text. But it should say, yes, the same number of time in the photos in total. And since we have 12 ladybugs pictured, we can then know that each ladybug was pictured twice in all of these 12 boxes. So we already know that, for example, the ladybug with 5 spots cannot appear here because it's already appeared twice. Which other ladybugs have appeared twice? Can you guys figure that out? What do you think, Leo?
Well, I can see only one 6. I can see only one 4. I can actually see two 3s. I can see two 1s. And there's only one 2. So I think the meaning of that is we get, in the last photo, a ladybug with 2 spots, a ladybug with 6 spots, and a ladybug with 4 spots. So let me just dot those in here. So, Joe, what does that mean the answer to this question is?
Well, the answer is asking for how many spots do the 3 ladybugs have in total. So we actually don't need to know the order. We just need to know which ladybugs are in there. So one has 2, one has 4, and one has 6. And when we add all those numbers up, we get 12 spots in total, which gives
Right.
us answer choice D. Oh yeah, a lot of you have been saying D in the chat. Man, this chat is getting so many of these right. Maybe you
Yeah.
guys should be teaching this.
Just another friendly reminder, don't send your messages to me individually or to Joe individually. Make sure you send them to Chat Relay if you want them to appear here on the bottom of the screen. And before we go into the answer slide, I want to showcase another solution you could have used to this problem. Oh, that's the answer slide. So if we instead considered the total number of dots for all of the photos, if we know each ladybug appears twice, how could we calculate the total number of dots, like not even knowing what the ladybugs in the last photo would be?
Well, we know each ladybug has 1, 2, 3, 4, 5, or 6 spots, and each of them is pictured twice. So we can actually just take the sum of all of the spots and then multiply it by 2.
Oh yeah. So maybe we use, how could we add up 1 plus 2 plus 3 plus 4 plus 5 plus 6? Do you know a good shortcut to do that?
Oh yeah, there's actually an excellent shortcut when it comes to adding all these numbers in Word. You actually just take the last number 6, multiply it by 7, and then divide by 2.
All right. So that would be 21.
Yes.
And then we can multiply that by 2 to get 42 total dots that will be pictured in all 4 images. And I've kind of obscured it, but how many dots would be in this first image?
I've obscured it too.
I see 1, 2, 5. So I think that would be 8 in this first image. In the second image, it's 1, 3, 6, which equals 10. In this third image, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in these first 3 images, I see 8 plus 10 plus 12 dots. How many dots therefore have to be in the last one?
Well, I mean, the total has to add up to 42. So if we let this be x, 8 plus 10 plus 12 plus x all equal 40, added together equal 42. If we add 8 plus 10 plus 12, we can get 30. So 30 plus x is equal to 42. And so that gives us the same answer as before, actually, which it should, because it's the same problem. We still get answer choice D, 12. This is a very neat other way to do it.
All right, so let's reveal the answer. It is indeed 12. So great job, chat. Let's go on to the next question. Ooh. So the question is, the construction uses 11 identical bricks. The construction has a length of 100 centimeters and a width of 60 centimeters. What is the size of each brick? Hmm.
Well, we have the dimensions of the thing, the construction. We have the height is 60 and the length is 100. These blocks are stacked very, very nicely with the height. So if we, oops, let me get my pen out. If we let the width of let's let this be the block. If we let this equal W for width and this is L for length, we can actually use some algebra to find out the height of the entire construction. What does that expression give us, Leo?
Well, if we apply this to the, did you say to the width? If you apply it to the width, I'm not actually really sure how to do this.
Oh,
But
to the left part of the construction. Sorry,
oh
sorry
yeah,
if I
if we
wasn't being very clear there.
oh, you're all right. If we apply it to the height, well, we can see there's kind of three different blocks that comprise the height on the very left. We've got this one's only showing using its width to contribute to the height. This one's using its length, and this one's using its width. So this height of 60 centimeters would equal 2 times W plus L. Do you see another way we can get an equation?
Yeah, I mean, there's more than one place where these blocks stack up to the top. Not only do they stack up all the way to the top on the left, but they do it in the middle here too, with this little bit, this little bit, this little bit, and a lot of little bits there, with 1, 2, 3, 4, 5, 6 little bits. And each bit, just like this bit over here, is the width of the blocks. So you can get another equation from that. I think that gives us 6 widths is 60. So we get 6W equals 60. And now we can solve these equations because we have 2 variables and 2 equations. Would you like to do the honors, Leo?
Well, for those who aren't so familiar with solving two variable, two equation systems, how about I show you a shortcut we can use in this case? So for more advanced people, there is a way to do this more efficiently or less efficiently, but a really efficient thing we can notice is that this this vertical block is spanned. This vertical block has the same height as these 4 horizontal blocks together. So we know the height has to be, or we know the length has to be 4 times the width. Does that make sense?
Yeah, it made sense to me.
I instead of finding the lengths and heights, let's first eliminate some answer choices. So looking at this first answer choice down here of 8 centimeters and 40 centimeters, 40 centimeters is not 4 times 8 centimeters. So we know it can't be this option. How about this option I've circled here, 12 by 40? What do you think, Joe?
Well, 12 times 4 is 48. And 48 is distinctly not 40. They're off by about 8. So it can't be this one either. Let's continue with D and E. Would you like to take a look at those, Leo?
Yeah. So looking at this option, option D, which is 8 centimeters by 44 centimeters, we can see, again, 44 is not 4 times 8. So it's not that option either. And going over to option E of 10 by 50, this doesn't work either because this one's 5 times instead of 4 times. That leaves us with only one option left, 40 and 10. But let's make sure it still satisfies the equations we found from earlier. Joe, will you do the honors?
Oh, all right. Let's go. If W, in this case, the width is 4. So the width is 10, sorry. The width is 10. So W equals 10, and the length is 40, so L equals 40. So 2 times W is 20. So 20 plus 40 does indeed equal 60. And for the second equation, 6 times 10 is indeed 60.
All right. I think we found the correct solution. Let's check.
All right.
Yes, it's B. And by the way, that was a challenging question. That's question number 21.
Yeah. Excellent job to everybody who was putting the answer in the chat. Let's go to the next problem. Ooh, we've upgraded. We've upgraded to grades 5 and 6. Ooh, there are going to be some harder problems. This here. Okay. I think I read this one, right?
Yeah, go for it.
Max puts slices of tomato, black olives, chilies, mushrooms, and onion rings on top of a pizza, but not necessarily in that order. He only put one ingredient at a time. His finished pizza is shown in the picture. What was the third topping that he put on the pizza? All right. So, any ideas on how to start this problem, Leo?
Uh, well, I know that this diagram must be useful somehow because they included it. So, how about I'll expand the diagram so you can see it more easily. Let's see, how can I do that?
I think if you move to the next slide, it'll just have the diagram on it.
Oh, fantastic. Okay. They knew exactly what I needed.
You have a nice big diagram so everyone can see it clearly. There's enough diagram to go around for everyone. All right. So, well, he puts them on one at a time. So, I mean, all the tomatoes must be put on at the same time, and then all the other things, and then all the like the chilies and the mushrooms and the other, what are the other Koreans again? There's olives and the onion rings as well. And so you can see some parts of the my computer is almost not making the mushrooms transparent, but you can see some things are on top of the others, which means that they must have been placed later. Can you spot any of these cases, Leo?
Yeah, I can see there's I think an onion ring, which I'm circling now. This onion ring here is on top of the tomato. So here we can do onion greater than tomato. And I can also see this mushroom is on top of that same tomato, so mushroom's also greater than tomato. And by greater, I mean that it's placed later.
The mushroom's not just on top of the tomato, it's also on top of the onion. So it's even higher on the list of things placed. What other cases? I think we've exhausted our options with this region. What if we move to another region? Like say, I don't know. You choose, Leo. What other regions do you think are useful?
Yeah, this tomato in the top left part of the diagram, we can see that this long chili here is on top of the tomato. So chili also has to be above tomato.
Yeah. But the question is it above mushroom and onion? Well, let's see. If we look a bit up right here, we can see that right here, the chili is above the mushroom. So it must go all the way up here. So that just leaves the dots. What are the dots again? Sorry, I forget.
I forgot to. Let me take a look.
They're black olives.
Yes, black olives.
Well, they're more like white olives here.
Yeah.
But let's see if we can find what order they're in. Let's see. Where are some of the black or white olives located in this diagram? Can you find any, Leo?
Yeah, there's one right here I've circled in yellow. It's above the onion ring. So I'll denote it with a B for black olive. And it goes above the onion ring. But another thing I noticed is that it goes below the mushroom because you can see the mushroom kind of on top of it. So I've placed it between onion ring and mushroom.
That's a good observation because it has to be between them. Black, olive. Okay. So now that we have the order in place, we have chili, then mushroom. In place first to last. We have tomato, then we place the onions, then he placed the onions, then he placed the olives, then he placed the mushrooms, Then he placed the chili. Let's go back to the problem and see what it's asking for. Let's see. What is the third topping he put on the pizza? Which one is the third one? Yes, it is. It is the olives. And so that gives us answer option. Sorry, which one was the olives again? It is B. Oh, you can see that a lot of people in chat are saying it's the olives too. Let's see if they got it right. You think they got it right, Leo? Oh,
Yes. All right.
wow,
Fantastic.
this chat is on fire. You guys are like what, like 6 for 6?
Yeah. Pretty much perfect so far. Or completely perfect so far, I think. All right. Next question. Oh, this one kind of reminds me of that pinwheel question. I think the question is actually related. So, Thea rotates a piece of paper divided into 6 equal parts. When the paper is rotated, it is turned clockwise by 1 part. As shown in this diagram here, it's like kind of turned this way. Or wait, is that right? Maybe this
Sorry.
diagram's no. It
Yeah,
should be
it's like
it should be turned this way actually.
yeah,
So like this way around.
yes.
The original sheet of paper and the result of one rotation are shown here, in case you forget. What does this sheet of paper look like after 8 rotations?
Well, 8's a pretty big number. But I
Hmm.
mean, at some point we have to have rotated it a full circle, right? What do you think, Leo?
Well, yeah, I think it's got 6 parts here. So after 6 rotations, we'd be back exactly where we started.
Yeah, that's a good observation. Since we're already back at after we started, after 6 rotations, that means doing 8 rotations is really the same as doing 8 minus 6 rotations, because 6 of those rotations do nothing. So really, the question is asking, after 2 rotations, what does it look like? What do you think, Leo? What do you think it looks like after 2 rotations?
Well, this can be difficult to visualize in your head, but we can see that this helpful pattern where you've got the 2 white triangles with a blank triangle in between, we can follow that. So uh, first it's in this part of this part right here, and then after rotating it once, it goes here. So I'd expect it to be on the top half, and that would be consistent with answer choice A.
All right. Oh, the chat seems to be in agreement with us. I think we got it if the chat's agreeing with us. Let's go see for ourselves. It is indeed A. 7 for 7. You guys are on fire. All right. Number 9. Let's see. 6 children took part in a race. Arya finished in the 3rd place. Biel finished 6th, just behind Ernest. Fatima finished between Arya and Ernest. And Diana overtook Charles right before the finish line. Who won the race? Wow, this is a lot of
Interesting.
people.
I'm seeing it's possible these A's are left over from last question, but I see a few different I see A's and C's in the chat, so this one's harder. Let's make sure we take our time with this question. But what's something we can eliminate right from the beginning? Well, from this first clue, Arya finished in the 3rd place. If Arya finished in 3rd place, she couldn't have won. So answer is not going to be Arya. What about the second hint? What does this tell us?
Well, I mean, Biel finished 6th, just behind Ernest. So just behind, that means Ernest must have finished right behind Biel. So if we like plot all of their positions here, this being number 1 and this being last place, we can safely put Biel in 6th and then Ernest here with with Arya in the 3rd place. Let's see what the next hint tells us. Fatima finished between Arya and Ernest. Well, I mean, what do you think, Leo? Where do you think we should put Fatima, Charles, and Diana?
Your mouse is like hovering right over exactly where I want you to put it. It's in the fourth position, so right between third and fifth.
Now that we have Fatima's position, now we can look at our final and last clue, which is Diana overtook Charles right before the finish line. That means Diana must be right in front of Charles, which puts our final order at Charles in second and Diana in first. Oh, a lot of you are saying C, Diana.
Some people, I see somebody is saying, "Isn't D Diana?" Because Diana starts with a D, and uh, that's why you have to pay careful attention to how these questions are written and what the answer choices are. So we can see Arya is answer choice A, but after that, it's all shifted down by one letter. So in this case, it would be Diana, but that's answer choice C. All right,
Excellent.
let's see the answer.
It is indeed C, Diana. You guys are right again. I don't know how you keep doing it. Oh, let's keep this streak alive with the next question. Ooh, this is a long question.
And yet another race, but perhaps a slower one.
All right. Sorry, should I read this one, or would you like to do the honors?
You go ahead.
All right. 3 turtles participate in a 10-kilometer race. Each of them moves at a constant speed, probably very slow though. When the first turtle finishes, the second turtle has covered 1/4 of the distance, and the third turtle has covered 1/5 of the distance. How far from the finish line will the third turtle be when the second turtle finishes? Well, for all these questions with loads and loads of words, I think it's good to highlight which parts are important. These numbers seem pretty important to me. This 1/4 and this 1/5, and this 10 kilometers too. What do you make of that, Leo?
Well, I drew them up in a diagram. So just to walk you guys through it, this yellow part is the whole race, and this green part is how far the first turtle went. This pink part is how far the second turtle went in the same time the first turtle finished the race. And this gray part at the bottom is for the third turtle during that same time period. So this is 1/4 of the way, and this one is 1/5 of the way. So for rate problems, often we have to calculate rates and worry about, like, can I add these two numbers? Can I take the reciprocal? But I think there's actually a shortcode we can use here, and it has to do with breaking the race into quarters. What do you think about that?
I think that's a great idea. I mean, if we break the race into quarters, that means that we know that each quarter, when the second turtle goes 1/4, the third turtle will always go 1/5. So let's say we break the race into quarters like this. Ooh, these quarters aren't that even, but pretend they are. Okay, I'm not that good at art. I do math, not art. But we know that it'll take the red turtle, the second turtle, it'll take them 4 times the amount they took to go this quarter to go the entire race. Then how far would the third turtle go? What do you think, Leo?
Well, in this green time period of the whole race, this first turtle goes a quarter, and the third turtle goes, or sorry, the second turtle goes 1/4, and this third turtle goes 1/5. So that also means for every fourth the second turtle goes, the third turtle goes 1/5. So let's advance time by another time period in which the second turtle goes another fourth of the distance.
Walks over here.
Where is the third turtle now?
Well, I mean, because the second turtle walked another 1/4, the third turtle must have walked another 1/5 then. So now that the second turtle is at 2/4, the third turtle should be at 2/5. Yeah. I think we can repeat this. What do you think, Leo? I think this is a repeatable thing.
Right. Let's do it 2 more times.
All right. Let's move from here to here. And then this is 3 arrows. And then finally, we need the fourth quarter, which is 4/4, which is equal to 1. And then we have the amount that the third turtle moved. And so since each time the second turtle moves 1/4, the third turtle moves 1/5. That means when it moves 4/4, the third turtle must have moved 4/5. So the third turtle has finished 4/5 of the race. But none of these answer choices are 4/5. I think there's some other information we need to factor in, Leo.
Yeah, I think there's two more steps, at least how I see it. So first we have to figure out what proportion do we have left for the third turtle to travel, which would be 1 minus 4/5, which is 1/5. But then I also don't see 1/5 as an option. And that's because we need to put it in terms of kilometers. Now, Joe, how far is this whole race again?
Let me check. Oh, I can see it. It's circled here. 10 kilometers. And so the amount remaining should be 1/5 of 10 kilometers. And so, hold on, let me change my pen color. This is gray. 10 kilometers times 1/5 gives us 10 over 5 is 2, which gives us answer choice B. Let's go see if that's correct. Oh, the chat seems to agree with us. That's pretty good. Would you look at
Voila.
that? The chat gets it right again.
No
They're like
surprise.
9 for 9 at this point. Or 8 for
Okay.
8. I don't remember. We've got a lot of them right, which is the important part.
Next question. Game, I see.
I like games. This should be a
Yeah.
fun problem. Would
So
you like to...
this picture shows 5 wheels of fortune. Each wheel is divided into a different number of identical parts. You will win a prize if you spin the wheel and it stops with a triangle above the wheel pointing to a part of the with the triangle pointing at a part of the wheel that is shaded. Which wheel gives you the best chance of winning?
Wow. There's a lot of wheels here. And they each seem to be divided into different parts. Can you think of any like techniques that would help with doing like with parts of a larger whole?
I think fractions are probably the right way to go with this problem. So expressing each of these as a probability is similar to what fraction of the area is shaded.
Yeah.
So in wheel 1, I can see there are 1, 2, 3, 4, 5, 6, 7, 8 parts, and 2 of them are shaded. So the probability here would be 2 out of 8, or 2/8. How about the second one?
Well, let's see. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 this time, and still only 2 of them are shaded. So this one gives us a probability of 2/10.
That seems definitely worse than the first one.
Yeah. I mean, there's still only the same amount of victories, but they occupy a smaller slice each time now.
I think we can eliminate that one right now.
Let's move on to the third one. What do you think, Leo?
Yeah, this one has 6 parts, one of which is shaded. And I'll quickly knock out the remaining ones. We have, for 4, oh, this is a lot of parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 of which are shaded. Again, this seems clearly less than 2/8, because only 2 wins, but even more losses than before. So we can cross that one out. And on this last one, 1, 2, 3, 4, 5, 6, 7. So 1 out of 7.
Yeah. I mean, we can use the same rationale as earlier with the 2/10 and 2/8 to knock out 1/7 compared to 1/6. Because again, there's the same number of winning squares, but it's just one less square. Pie slices, not squares. So you can knock that one out too. So now it's a competition between 2/8 and 1/6. If only there were a way for us to look at these make them more similar to each other so you could compare them more directly. How do you suppose we could do that, Leo?
We could simplify 2/8. So 2/8 we can think of actually the same as 1/4. So notice how I've shaded the same amount in, actually I've shaded 0. Notice how I've shaded the same amount in both of these. They're just subdivided further in this left one. And in that same way, we can say the number 2/8 is equal to the number 1/4.
Now after this, you go.
Now all we have to do is compare 1/4 and 1/6. And like Joe said earlier, 1/6 is greater than 1/7. And similarly, 1/4 is greater than 1/6. So our answer should be answer choice 1, or answer choice A, rather.
Let's see. The chat seems to agree with us. Do we put our faith in the chat? I mean, they've been right so far.
I believe the chat. And there it is.
Absolute cinema. Let's go to the next one. Ooh, this might be our final problem for the night. Ooh, looks like a tough one too. Oh, my school's swimming team. Oh, my school's swimming team is great. My school's swimming team is practicing for a relay competition. 5 swimmers swam the same distance, one after the other. The pictures below show the times on their coach's stopwatch when each swimmer finished their leg. The first swimmer needed 2 minutes and 8 seconds. Which of the swimmers needed the least time? Ooh. How do you suppose we can get started with this problem, Leo?
I think we should figure out how long each swimmer took, and then we can compare to see which one is the fastest. So obviously, maybe we can give them names. So the first swimmer could be Annie. So Annie, I'll abbreviate Annie with just A. Annie is just 2 minutes and 8 seconds, but that's the only easy one that the problem gives us. The next swimmer went from 2 minutes 8 seconds to 4 minutes and 7 seconds. Therefore, it took that swimmer the time in between to swim this same course. So what should we do with these two stopwatch readings?
Well, I mean, let's give this second swimmer a name. Let's call him Bill. So Bill took the time between 4 minutes and 7 seconds and 2 minutes and 8 seconds to swim the entire lap. So he must have taken the final time minus the initial time to go the entire way, which is the change in time, which is what we're looking for. So what's 4 minutes? Well, there's a neat way to do 4 minutes and 7 seconds minus 2 minutes and 8 seconds. Because although we could go and like convert these all to seconds and then like go with like a bunch of larger numbers, there's a quicker way to do it by observing that 4 minutes and 7 seconds is one less than 4 minutes and 8 seconds. And we know that the difference between 2 minutes and 8 seconds and 4 minutes and 8 seconds is exactly just 2 minutes. And since we know that 4 minutes and 7 seconds is just one less, we know that he took just one less second than 2 minutes, which gives us 1 minute and 59 seconds for Bob or Bill. I think I called him Bill. Yeah. What about the third person? What do you think, Leo?
So our third person, whose name is Charlie, is going to take between 6 minutes and 10 seconds and 4 minutes and 7 seconds. Again, we have to subtract. So this would give us I'll do it out on paper. So 6 minutes and 10 seconds minus 4 minutes and 7. That would be 2 minutes and 3 seconds. And for the next one, whose name is Daniel, it's not included in the problem, but I can assure you his name is definitely Daniel. We have 8 minutes and 5 seconds minus 6 minutes and 10 seconds. Now, we could use a smart shortcut like Joe showed us earlier, but let's say you couldn't come up with this under the stress of the test. Well, we can use a similar tactic to just basic subtraction, something called borrowing. You know about borrowing, Joe?
Yeah, I think I've heard of it before. I mean, it's the same technique as subtraction, where we can like borrow from bigger numbers. Like, for example, 5 minus 0. Well, I mean, 5 minus 0 is just 5. But 0 minus 1, that's a negative number. And so just like with regular subtraction, we need to borrow from the bigger digit. So we replace this 8 with a 7, and then we can add some number here. But wait, this isn't regular subtraction. You can't just add a 10 here because 1 minute is not worth 100 seconds. 1 minute is worth 60 seconds. So we actually replace this with a 6.
Exactly. Kind of like when Joe borrowed the candy bar I gave him, he replaced it with an empty wrapper, unlike 60 individual candy bars, like pieces that I expected him to.
Yeah.
Anyway, this would be 7 minutes and 65 seconds minus 6 minutes and 10 seconds. I'm in the mood of borrowing. Let's do another one. So this. Oh, wait. We actually don't need to in this case. Let's just proceed with the problem. So 5 minus 0 gives us 5. 6 minus 1 gives us 5. And 7 minus 6 gives us 1. So David took 1 minute and 55 seconds.
Ooh, that's our fastest time so far. He might be on the track to winning this. Let's take a look at the final one just in case. E. We'll call him Eli Bartholomew. Eli Bartholomew. Yes. Great friend. Personally know this guy. Let's see. 10 minutes and 3 seconds minus 8 minutes and 5 seconds. Well, we've already gone over a number of ways to do this. So which way would you like to do, Leo?
Let's do the borrowing trick again. So we can borrow this 10 and replace this ones with a 10, and then replace that with a 9, as we're going to borrow over to here, and that would be 6, and replace this 6 with a 5, and this becomes 13. Actually, I'm going to rewrite that so you guys can see it more clearly. So one more time. That's borrowing this 1 from this tens place here in the minutes and replace this 1 minute place from 0 to 10, and then immediately borrowing that to be 9, because we're going to make 10 seconds, or 60 10-second periods, and then also borrowing that one so we can make 13 1-second periods. And 13 minus 5 is 8, 5 minus 0 is 5, 9 minus 8 is 1. So 158. Not bad, Eli Bartholomew. But who's the overall winner?
Well, I think we have to look at the winner. Let's see. Let's see what the question's asking for. We wanted the swimmer with the least time. And out of all these numbers, the smallest is David's or Daniel's. I don't remember what we called him. But 155, which gives us the answer choice of D, the fourth. also known as Daniel. Okay, ooh, the chat really seems to be agreeing with them. There's people that are putting 3 or 4 Ds in the chat. You seem pretty confident this time. What do you think, Leo?
I believe the chat. And let's see the answer. All right. It is indeed D. So I think we've been pretty flawless today. What is that? Maybe 8 for 8, 9 for 9? I don't know.
Yeah. Excellent job to everyone. I think that is the last problem we have today, though. All right. So it's absolutely a pleasure to be doing this live solve. Thank you all to you all in the chat. You guys were excellent. You guys all got like, I don't know, all got 100s in this live solve. Okay. You know, as one of the 2 people running this live solve, I give you all in the chat a 100%. What about you, Leo?
I would also give the chat 100%. And yeah, that's all we have time for today. So remember, the Math Kangaroo is March this year. I believe the third Thursday, which is a bit of a mouthful. So make sure you mark your calendars, and that is all.